Your body can start a movement before your brain is fully aware of the danger. That's not a glitch. It's a safety feature called a reflex. So how does that happen so quickly? In this video, you learn what reflex actions are, how the body produces them so quickly, and why the spinal cord plays such a big role. By the end, you'll be able to trace the signal from stimulus to response without mixing up the parts. Let's start with a definition. Reflex actions are involuntary responses to a stimulus. Involuntary means you don't stop and think first. Your body reacts automatically. To make that concrete, let's ground that with two examples. Heat is a stimulus, and pulling your hand away is the response. Bright light is a stimulus, and your pupil shrinking is the response. In both cases, it happens fast and automatically. So what's happening during a pull-away reflex? When your hand gets close to a flame, heat triggers sensors in your skin. Before you can calmly think, "That's hot," your muscles are already pulling your hand back. That speed comes from a quick pathway called a reflex arc. Here's how the signal moves. First, a sensory neuron detects a stimulus, in this case heat, and carries a message from your skin toward your spinal cord. These neurons can be surprisingly long, which is why the message travels along them like a signal on a wire. In many situations, signals go up to the brain for processing, but in a reflex, your body doesn't wait for the brain to decide the first move. Instead, inside the spinal cord, the sensory signal is passed to a relay neuron. You can picture this as a fast handoff. One neuron passes the message along without delay. Next, the relay neuron passes the signal to a motor neuron. The motor neuron sends a command to a muscle. The muscle contracts, and your hand jerks away. Put together, that pathway is the reflex arc. The signal travels from a sensory neuron to a relay neuron in the spinal cord, then to a motor neuron, triggering a fast response that helps protect you. So far, we've defined reflex actions and traced how a reflex arc uses sensory neurons, relay neurons in the spinal cord, and motor neurons to produce a rapid response.
Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you.
Now let's apply the same idea to a different situation. If you step on something sharp, pain signals travel in, and your foot lifts it right away. Same logic, fast protection first. Follow the pathway again. Sensors in your foot detect the stimulus. The sensory neuron carries the message to the spinal cord. A relay neuron passes it along, and a motor neuron activates muscles to pull your foot away. Right after that, your brain still gets the message. That's why you feel the pain and realize what happened, even though the movement started before you chose it. And here's a common misconception. Reflexes don't mean the brain is left out. The brain is informed. It just isn't running the first, fastest response. That said, reflexes aren't perfect protection. They're fast, but not magic. If the stimulus is strong enough or contact lasts too long, damage can happen before you fully pull away. And reflexes aren't only about pulling away either. For example, if something flies toward your face, you blink automatically to protect your eyes. Different body part, same core idea. A stimulus triggers an automatic response. Overall, reflex arcs matter because they help you survive. They buy you time by reacting immediately, while your brain processes what happened and decides what to do next. To recap, reflex actions are involuntary responses to stimuli. A reflex arc routes signals through a sensory neuron, a relay neuron in the spinal cord, and a motor neuron. Your brain still learns what happened, but it doesn't control the first fast move.
Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.